Good day everyone, I am JL Tuyan BSCE3. In this video, I will be talking about the standard devices in building a telecommunication system. So building a telecommunication network involves using standard devices to facilitate communication. These devices include routers, switches, modems, and transceivers. So first is router. It directs data between different networks. Next is switches. It manages local connections. Third is the modems. It converts digital signals to analog for transmission over traditional phone lines. And transceivers handle wireless communication. These standardized components ensure interoperability and efficient data transfer within the telecommunications infrastructure. So in the realms of telecommunications, telephones serve as fundamental devices facilitating voice communication over long distances. These standard devices have evolved significantly since Alexander Graham Bell's invention in 1876. Modern telephones come in various forms, ranging from traditional landline phones to sophisticated mobile devices. Landline phones disconnected through wired networks remain prevalent in homes and offices, providing a reliable voice communication. On the other hand, mobile phones leverage wireless technology, enabling users to make calls on the go. So the integration of the advanced features such as touch screens, cameras, and internet connectivity has transformed telephones into multifunctional communication devices. Key components within telephones include microphones, speakers, and circuitry for signal processing. Microphones capture the user's voice, converting it into electrical signals, while speakers reproduce incoming signals as audible sound. The circuitry handles signals transmission, converting analog voice signals into digital data for efficient long-distance communication. Moreover, mobile phones incorporate additional components like antennas or wireless connectivity and touch screens for user interaction. This standardization of communication protocols such as GSM or the Global System for Mobile Communications ensures interoperability, enabling seamless communication between different telephone devices, and networks globally. So as technology continues to advance, telephones remain at the forefront of connectivity, bridging distances and fostering communication across the world. The integration of innovative features, coupled with adherence to communication standard, underscores the enduring significance of telephones in the ever-evolving landscape of telecommunication. The private branch exchange or the PBX systems are foundational components in telecommunications, serving as central hubs for managing and routing voice and data communications within organization. These systems enable internal communication among employees and facilitate external calls to the public telephone network. PBX devices come in various types, with traditional on-premises systems and modern cloud-based solutions being prominent examples. In a standard PBX setup, on-premises system consists of hardware components such as servers, telephone lines, and handsets. This system manages incoming and outgoing calls, voicemail, call forwarding, and other telephony features. They provide business with greater control over their communication infrastructure, allowing for customization and integration with other technologies. On the other hand, cloud-based PBX systems leverage the internet to deliver similar functionalities without the need for extensive on-site hardware. These scalable solutions offer flexibility and accessibility, making them appealing for business seeking cost-effective and agile communication solutions. PBX systems play a crucial role in enhancing organizational communication by streaming internal and external interactions. They contribute to increased efficiency, reduced communication cost, and improved collaboration among employees. As technology advances, PBX systems continue to evolve, integrating with unified communications platform, artificial intelligence, and advanced analytics to further enhance the overall communication experience for business of all sizes. Next is router. So the router plays a pivotal role in the realm of telecommunications, serving as indispensable devices that facilitate the flow of data across networks. At their core, routers are equipped with the ability to analyze incoming data packets, determining the most efficient path for them to reach their destination. This process, known as routing, is fundamental to the seamless functioning of modern communication networks. Routers operate at the network layer of the OSI modem, ensuring the efficient transmission of data between different devices on a network. Standard routers are endowed with multiple ports to connect various devices, such as computers, smartphones, or other networking equipment. They serve as the central hub through which data traffic is directed, enabling devices within a network to communicate with one another. Additionally, routers often incorporate features like network address translation or NAT to manage the allocation of IP address, enhancing the security and efficiency of data exchange. So, in the context of telecommunications, routers play a crucial role in connecting disparate networks, whether on a local scale within a home or business, or on a larger scale across the internet. They form the backbone of the information exchange, ensuring that data reaches its intended destination swiftly and accurately. As telecommunications technology continues to advance, routers evolve to meet the increasing demands for speed, security, and reliability in the ever-expanding digital landscape. Next is switches. So telecommunications networks rely on switches to manage the flow of data efficiently. Switches are fundamental devices that operate at the data link layer of the OIS model. They play a pivotal role in directing data packets within a network, making decisions based on MAC addresses. Unlike hubs that broadcast data to all connected devices, switches analyze the destination MAC address and send the packet only to the intended device, reducing network congestions and enhancing overall performance. There are two main types of switches, the unmanaged and the managed. First is the unmanaged switches. It operates automatically without user configuration, making them suitable for simple setups. On the other hand, managed switches offer greater control and customization. Network administrators can configure managed switches to optimize traffic, implement security measures, and monitor network performance. This flexibility is crucial in large-scale telecommunication networks where efficient data routing and security are paramount. In a telecommunications infrastructure, switches are strategically placed to create a network topology that suits the organization's need. Whether using a star, ring, or mesh configuration, switches from the backbone of the network, facilitating seamless communication between various devices. Their ability to intelligently forward data based on MAC address ensures reliable and efficient data transmission, making them a cornerstone in the architecture of modern telecommunication systems. So, next is firewall. In a telecommunication setup, firewalls play a crucial role in network security. Standard devices include hardware or software firewalls that monitor and control incoming and outgoing network traffic. They enforce security policies preventing unauthorized access and protecting against cyber threats. Firewalls can be stand-alone appliances or integrated into routers. Configuration involves defining rules to filter traffic based on criteria, like IP addresses and ports. Regular updates and monitor are essential for effective cybersecurity and telecommunication networks. Modems. Modem, short for modulator demodulator, are pivotal devices in telecommunications facilitating the transmission of digital data over analog communication channels. Standard modems are operate by modulating digital signals into analog waves for efficient transmission over telephone lines. On the receiving end, they demodulate the analog signals back into digital data. Two prevalent types are dial-up and DSL modems. Dial-up modems establish connections through standard telephone lines, albeit at relatively slower speeds. In contrast, DSL or digital subscriber line modems optimize existing telephone lines for high-speed broadband internet, employing advanced modulation techniques. These standard devices play a fundamental role in bridging the digital-analog gap, enabling widespread internet access and communication. Next is cabling and wiring. From the physical infrastructure that connects these devices, ensuring the smooth flow of information. Ethernet cables, commonly used in local area networks or LANs, provide a reliable and high-speed connection between devices. Fiber optics utilizes light signals, offer even greater data transfer rates over longer distances. The structured cabling system, comprising standardized connectors and wirings, ensures uniformity and ease of maintenance. Well-designed cabling is essential for minimizing signal interference, optimizing data transfer speeds, and enhancing the overall efficiency of a telecommunication network.